Hello to the next stream, design stream, focused on the simplest, I don't know if simplest, but I will fight for it. Module with STM32MP215 MCU. No, this is not MCU, this is MPU. And I'm doing it because I want to work on a design publicly where there is MPU or CPU and the DDR memory. This time it will be DDR3 because of the market availability, price, everything. And this MPU supports both DDR4 and DDR3 as stated in the official announcement or application note. No, it was an announcement on the st.com website or product page of the STM32MP215 or 2X, or yeah, the entire family. The ST reacted to the market situation and stated and tested and have tested or had tested before that announcement that both DDR4 and 3 are supported, and they published a list of all memories, so I chose one. It happened in the stream number 2. Yeah, today is part 4, and last time I mentioned that I already received the STM evaluation kit with the 215 MPU, and that I was planning to test it, but I didn't test it yet because I didn't have time for that. So let's start with symbols, and I hope everything is as should be. Everything is running. I mirrored my camera in the StreamYard setup. So now in the dashboard of the StreamYard, I see that my camera is mirrored incorrectly, but I can't see the final stream right now. So last time with the mirrored camera, I was looking to the edge of the screen always. Now I should look inside of the screen, but I'm not sure because I struggled with it in the past. So another option is to create my own. Yeah, I can. My own, let's say, how to say, layout. Yeah, stream layout. Now I'm using the I can see that I can. Oh, okay. I can make some changes online. Okay. Anyway, if it doesn't work today in this stream, I will redesign my layout. I don't know how. Yeah, this is a complete. Yeah, I'm playing around with the layout. Anyway, let's get back to work. Schematic is here. Last time MPU, PMIC, micro SD, let's check it. Micro SD, these two are obsolete, and this is Yeah, this one I was using last time. Yes, this one in the last design with the carrier for the Raspberry Pi 4S, Compute Module 4S. And let me add GLCP-CB code for it if possible. Yeah, for sure. These electromechanical parts are the best to be sourced from the Chinese manufacturers because they have much better price and yeah, much better availability. But this time I usually source these connectors and electromechanical parts from Mouser or DigiKey, not usually from China. So yeah, this is not designed to be manufactured in China, so I will keep this as a not well available part, but in the case of a need, I can redesign the connector because many of them are, let's say, copied or adapted for Chinese market. So usually these parts are manufactured in China anyway, so yeah, they can share the manufacturing process. And sometimes it happens that the Western parts are manufactured in China under Chinese part numbers, but are exactly the same. I don't want to generalize, but this sometimes happens. So micro SD will be this one. Peripherals will be used all. This is the DDR4, not available. DDR3 is here, and we will work with this. My note from the last time or from the part 2, yeah, doesn't matter. SnapMagic has symbol plus footprint, and UL is Ultra Librarian, has 3D model. So let's get to SnapMagic with this. SnapEDA or SnapMagic, the same tool, same library. By the way, have you tried their Copilot? I can see here is something like a Copilot, but I haven't. Please give me a comment or yeah, your opinion about that. So let's check quickly the part number, because sometimes it happens that you enter the full and correct part number and the library returns a similar, but not the fully, not the same part number. And sometimes it can cause issues because, of course, when you find and use a different symbol with, for instance, different pinout or some missing pins, some extra pins, because if you use the symbol for higher density memory or lower density memory, yeah, you understand that can happen a disaster. So this is fine crafted symbol, I can say, and the footprint. By the way, SnapMagic or SnapEDA footprints are much better than Ultra Librarians, almost always. When there are footprints and symbols available at SnapMagic, I always grab them, because Ultra Librarian sometimes are, let's say, suboptimal. So download part. Downloads, KiCad pool, and Ultra Librarian for the 3D model, as we said. It's not a unique symbol, it's a very common BGA, maybe even in the standard KiCad libraries, but should we check? Yeah, we can. We can, because even the footprint can be there. So it's BGA, DDR, micron. Yeah, something is there. It's yeah, we need footprint. We need footprint. We need footprint. Mouser. I sourced from Mouser. Yeah, we are not robots. This part, last time it was available. Yes, still available. Life cycle is unclear. Huh? Yeah, it's quite older part, but what can we do? Data sheet. Yeah, I remember from the last time. Yeah. See data sheet. See? Good. Oh, can I use this link as a datasheet link? Yeah, probably yes. Okay, footprint. It's 96 ball, 8x14, and the pitch is. We have to check the footprint drawing. Here is. The pitch is 0.8. It's extremely comfortable to solder footprint. Yeah, it's BGA, but 0.8. It's more than TSSOP. It's more than most of your QFNs. Most of your QFNs has 0.65 or even 0.5. Sometimes 0.4, which is crazy. Fine. Yeah, I'm happy for this footprint. So 96 ball. 14 times 8 and 0.8 is the pitch. So let's check. Let's check the KiCad library. 96. 8x14, 8x14. Yeah, 8x14 micron. 8x14. I don't understand the difference. Yeah, the layout is like the cartridge probably. I don't understand the layout numbers. This cartridge is 16 times 10, so it's not the layout. The layout, oh, I don't know. But the part is 8x14. That's fine. That's correct. The pitch is 0.8, and let's check. 12 from up to the from the top to the that's the result of the pitch times the number of pins in the column, but this 6.4 is more important for us. Yeah, thick 6.4. They say 6.4. KiCad says That's fine. The height of the package is not important. Yeah, it means that this footprint is correct. Okay, let's check its 3D model. It's missing. Okay, so I have to download it from the I don't know what this code is, from the library, but the footprint is ready. And if the footprint is ready, what about the symbol DDR memory? DDR4, 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 DDR3. It looks like a oh, I see that code was for the delivery that I'm expecting. Okay. So please, yeah, you understand. I will have to pick up the delivery, but in an hour or so. Yeah, probably the stream will be over that time. Okay, back to the symbol. Here is the symbol. The symbol looks good. I have to check it with the datasheet. So I need this. And I have to check the schematic symbol. This, okay. Probably this is schematic in the datasheet. Yeah, of course it's not, but there is nothing better. Okay. And in this table are no, just the types. Okay, so I have to check it. The original symbol, which is this one, yes. And I have to check in the table view here. Sorted by numbers, A1, VDDQ, yes, A2, DQ13, A3, DQ15, A7, DQ12, VDDQ, VSS, okay. It seems that it works. C1, for instance, VSSQ, VDD, C2, VDD. No, C2 is DQ11, yes. C3, DQ9, yes. C7, UDQS, yes. DQ10 and C9, VDDQ, yes, it works. Let's say this N1 is VDD, N2 is A3, N3 A0, N7 A12, BA1 and VDD. Okay, it works. And the last T1, reset A13, A14, A8, A7. Okay, the symbol looks good. I will make some double checking using Claude or yeah, some LLM, but it looks good. Okay. So I can copy this into my library, of course, under the correct part number. Here it is. Yeah, it even points, or yeah, links the, no, incorrect. Here is an incorrect library, so I have to assign this one. Yeah, this one was checked, 8 to 14 with the strange layout numbers here, but the pitch is the same, and I checked the dimensions correct. They say that the datasheet, the GKey, has the correct datasheet, but last time I checked, it doesn't. Here is the description. So this is for 64 MB, 16-bit, 8 banks. That's correct. DDR3, yes. 135 is, yeah, the automotive voltage level. Yeah, I can even place the range because sometimes it's important for PMICs. Revision is not important. FPGA, yes, and our dimensions are 8 times 14. Okay. Here will be MOC. No, not this one, but this one. Supplier Mauser. JLC. We will have to check it, but I think there's no way. Oh, it is quite well available. For higher varies that Mauser, but yeah, they have it. $40 at Chelsea PCB and Mauser. 2860, let's 62 USD, no, euro to USD. 33, yeah, it's more expensive, but yeah, that's good. I didn't expect it. So memory, DDR3, oh, fine. We have our symbol. Let's check it. No issues found. Let's get back to the footprint editor because we had to add the 3D model from the Ultra Librarian. Here is 3D model, download 3D model step. So it was faster than I thought. I am surprised. Yeah, we can download it to the KiCad pool. Here is our KiCad pool, librarian. Yeah, and it's FPGA 96, 8 times 14 millimeter, pitch 0.8, and that's basically everything. We can add micron. Okay. 3D models. Did I copy it? Yeah, I did. Here. I say micron. It will be probably the only one with micron in the beginning. Yes. Yes, it works perfectly and looks really good, amazing, beautiful. Okay, fine. It means we can check DDR3, symbol is ready, footprint is ready. Ethernet, okay. KiCad library, it will be fast, hopefully. So, here it is. Here it is. Single, it's so small package. I didn't expect it. I didn't expect so small package. Yeah, this is the data sheet. We don't need it. eBay. What's eBay? Why is there eBay? Yeah, 24 PET package, 4x4, yeah, small one. Yeah, that's good. That's nice. No issues found. Yeah. Yeah, I forget to check the DDR3. Should I? Yeah, probably yes, but yeah, maybe later. I'm lazy. All the memories are under the JEDEC consortium, and the pinouts are controlled by the standard, so usually it works. This is why all your SPI flash memories are the same pinout. This is the same as the standard logic, the same as op-amps. Yeah, not all the op-amps, but yeah, the standard range share the same pinout. This will be the case as well. Communicators. Yes. Let's edit the attributes. Let's check if the datasheet works. It works. Here is the package. Thermal vias, okay. RMI, okay. MOC is not this one. This one. Supplier was Mauser. JL. Where is the JL here? Extremely well available. 10,000, almost 11,000 pieces. Ethernet, II. Okay, and I said we have to work on the footprint. I have it in the memory here. Here is the footprint used by the KiCad standard library, but it doesn't mean anything. I have to check the footprint datasheet for the recommended footprint. Recommended footprint from the datasheet is what I take as a golden standard for each component. because anyone who creates these libraries, either at SnapEDA, Alt library, and KiCad standard libraries, anyways, not some text, how they call it, the other one can be wrong. So footprint. Oh, the word footprint is at each page. Landing pattern, not pattern. 6. Okay, so let's get to the end of the datasheet. Package. Oh, package. I did not check the package. Here is the package. Fine. Yeah. C. PCB length pattern. No, it is. Here is pattern, but yeah, probably the last occurrence. Okay. So they say we don't need vias. The user may modify the PCB length pattern design and dimensions based on their experience. Okay, I don't have much experience with this particular package, or I suppose I don't have. I'm green because I want the error-free design. Exposed tolerable copper area of the center can be either solid or segmented. Okay. Maximum thermal and electrical package performance is achieved when an array of solid vias is incorporated. Okay. So they say we can use the vias. Okay, so I will use the KiCad package, but you will see that I am right. I'm correct. These vias are 0.2, which is too small. And as we said, 2 parts in the past, in the part 2, the original design of this evaluation kit is on PCB, 4-layer PCB. So it's not optimal. It's not optimal because there is no reference plane next to each signal layers, because I think layer number 2, which is first inner layer, was power, not ground. So it's suboptimal. 6-layer PCB should be better, and I'm not sure if we will use the 6-layer or 4-layer. We will have to check the JLC PCB. I already did it, but I can't remember the numbers. But yeah, I will probably use the 6 layers. So I want to say that 6-layer PCBs has, I think, smaller minimal vias. Well, we can check it, but not here. Here, capabilities, minimal via drilling, hole size not, we want vias, not supported per it, minimal via hole size 0.15. Okay, it's okay. But when we use this, put footprint on 4-layer, which is possible because this LAN driver is can be placed on a 4-layer, even on two-sided boards. The 0.2 vias are too aggressive. Exposed pad size. Okay, so JLC works. Exposed pad D2, E2, 2.5, 2.5, that's fine. Pitch is 0.4, yeah, as I said, the BGA have the pitch of 0.8, and this small, simple QFN for the LAN has 0.5, so much more aggressive for the DIY soldering. And the vias are 0.2. Yeah. And I want to save time, so the pitch is 1 millimeter. Okay, so I can remove all of these, and use create from selection, horizontal spacing 1, 1. Source items here, pet start is 25 and increment is 0. Voila. Yeah, this is what we want. The car chart is, let's say, too complex, but I will keep it, and I'm checking the 3D model is missing. Okay, let's check the standard libraries, because sometimes there is missing because they use the generic names, and the exposed path, for instance, is something that is not present in that particular package. 3D models package DFN here. We are looking for 24, 4 times 4. I need this window to be bigger. I really missing here the search field. That would be genius, but maybe sometimes in the future. Okay, to QFN, for instance, this one, QFN 24, 44, 0.5. Doesn't matter, the exposed path is totally unimportant for our package, and as you can see, it works great. Yeah, animals. Okay, so let's get back to symbol. We have to assign our symbol, QFN, VQFN 24. Yeah, this one. This is the one. Yeah, that's it. Fast check, 15 is reset. Where is the pinout? Here. 15 is reset. Another check. 22 RxN 22. Good. 9 VDD IO. Good. And the last one is 2 LED2 in cell. Yes. Okay. Symbol should be fine. Yeah. VSS. Passive. I like the grounds to be passive. But if you ask me why, I wouldn't say that I lost the reason. Yeah, in the past I've struggled with some ERCs because the power input VSS or ground ports causes some false findings, but I think it's not valid anymore. But I sometimes change it if it catches my attention. Okay, so LAN is correct. Ethernet X. This M2 connector, let's check it. Let's make a quick check. Yeah, the standard, yeah, not so nice as in the reference design, but it doesn't matter. Okay, that's good. A USB, I will do it. I don't know what does it mean. I really don't. Docs. DK. DK. USBs. USB. USB plus eFuse. I will do it. I will do it. USB Type-C is here. This is a standard full featured USB. I can check the footprint, not footprint, part number here. From Amphenol, yeah, that's something I have in my library. This receptacle flat, this is the VE, yes. I think I supplied this from DigiKey, and I have to check the JL. Quite expensive, yeah. This is something, if you want to manufacture in China, you should focus on the USBs. The Western, or let's say the global parts, are crazy expensive in China, and I'm pretty sure you can find the same connector with almost the same pinout for under $1. And I'm using this one because I have a stock of about 20 pieces in my lab, and yeah, I don't want to buy a better one. So yeah, but I can see that this should be the one. Yeah, the other one. Yeah, this is the same. 60. No, this is not the same. This is not the same. That one was designed for 1.0 millimeter PCB, and this one is for 1.6. The footprints are the same because the thickness doesn't matter, but the real part is different. So this one. USB and eFuse. Okay, eFuse will be used the same. I know what I said by I will do it. I will do it means I have to create symbols. Yeah. This is the eFuse. I sourced it from Mauser. I have it on hand already. It's pretty normal. Yeah, the availability is limited, but I have it, and I don't want to change it because, yeah, don't ask me why. I don't know why. This circuit sets the current limit to something by this 47 ohm resistor. So let's check the data sheet for the real limit. We have to find a formula for it somewhere. Current limit. Yeah, something like this. We are using 47, so lower than 1. Let's say, yeah, the 22 means 2, 50 means 1.1, and we have somewhere between, so more than 1 to 1.1. Yeah, I have some eFuses in my library, but I bought it because I didn't want to change so many things. It's not what I want. Yeah, let's check the library. I think it's nothing in there, yeah. eFuse Yeah, this is one. This will be adopted. Okay. Split screen. That's quite aggressive split screen. So this is our yes symbol. This is our data sheet. So I limit is number 1 input. I would say it's passive. Fault is 2, and it's not fault is at restate bidirectional interface. So it's bidirectional and not negated. Okay. DVDT. How they created the, yeah, this is capacitor. So here. Oh, I lost my window setup here. DVDT is number 3. DVDT. It's passive. Okay. Ground is number 4. 4. Passive. There is no exposed pad because it's a plastic package. Here is, yeah, I will copy the this symbol. So input voltage is VCC is VBus and Vout is 5.6. They say source Vout. Yeah, Vout, okay. Source of the MOSFET, sure. Yes, probably. Probably, I don't know. Yeah, connected to the source of the internal MOSFET, okay. So out is 5, and there is another output 6, and is passive and invisible. Then we can stack them, okay? And VCC is 7, our input. And there is another one, 8, sure. Invisible passive. This time we can stack them. Okay. Now table view. 1 is I limit. Okay, I will change the name to I. How to create the, yes, the index, lower index, underscore, and in the brackets the name of the pin. It's too big. This table is too big. Okay. Number 2 is enable fault bidirectional. Okay. Number 3 DVDT passive. Number 4 ground. Number 5 output. Number 7 output. Okay. V out both. Yes. And yeah, we can have nice symbol. So 3 VDD, 4 VDD, 5, 6 source, 7, 8 VCC. Perfect. This is our lovely symbol. Attributes. Attributes are subject to change. 𝗞𝗶𝗖𝗱, we have to check the footprint because TSSOPs can bite your butt, bite your ass easily. So we are looking for TS23. So 23. Oh, 23.8. Yes, this is in my library, but we have to check it. 2.5 is the page between centers of the pads. 2.3, yeah, we have to change it. And 1 times 0.45. Longer, okay, we have longer pads. 0.4 is the distance. Yes, that's correct. Yeah, I will change it. This is better. Yeah, it doesn't harm any previous designs, because as you can see here in the 3D model, yeah, the pad is long enough. Okay, so this package is correct. SOT 23.8. Yeah, they say TSOT, but it's like the thin package, but yeah, it's the same footprint. This is the data sheet. The data sheet said it's a 5-volt E-fuse with 25 V in. What's the minimal? Recommended, okay, C5 to 55, okay. So the 25 is the absolute crazy high limit. Output current is given by the current limit, which is what? 3.3, 3.5. And the package is SOT 23.8. This is our part number. I supplied from Mauser and JLC. Oh, I can kept it this small because I will use it in the future, probably. This is the JLC number. Okay, let's check the symbol. No issues. Fine. Symbol looks good. And we can mark it as finished. Okay, the last one is, yeah, the last two, peripherals and UART. So I will continue with UART. Let's check what's there. Don't know. Okay, this is not UART. It is. It's M2. UART. Okay, I see the UART is a node that we need UART terminal or debug interface. Okay. Okay. So how they treat the UART? Here is the UART, full UART for path UART coming to the or going to the M2 connector. Okay. Okay, so we just need the header. Okay, not this one. This one. Let's say UART pin header. Yeah. And here is control SD MMC. Yeah, here are level translators, but I'm curious why. Okay, probably from the PCB layout perspective was better to use two packages instead of one 8 port package. Yeah, that makes sense. I sometimes do it again as well, because when the tracks or signals are coming from both directions, from multiple directions, it's better to separate the streams into two packages. Yeah, that's probably the reason, and we will most likely face the same issue. Yeah, well available. This is the TXB, which is designed for push-pull operations. If you want open drain and push-pull, you have to go for TXS, which is slightly slower, about an order of magnitude slower, but accept both open drain and push-pull. It means you can use it for both I2C, SPI. Otherwise, you have to split it. Okay, so I think I have something in my library. Not this one. The XB, I have 8-pin. No. Oh wait, there is a code. Oh, I see. I was wrong. I was not correct. The 3-4 means 3 of them are. Yeah, let's check the datasheet. It usually means that 3 are inputs and 1 is output. No. It's bidirectional. So I was wrong. So what's the difference between? Oh, maybe absolute voltage level. As I can see, the 0104 accepts 5.5 at the B side. Here is missing on port B, on B port, but it doesn't matter. Yeah, what did Jimenez says about that? Yeah. Input impedance and here's the protection levels, okay. So yeah, 0104 is up to 5.5. Okay, this one goes from lower voltages. So slower, fast, fall time, rise time. And okay. Ultra low voltage applications, okay. That's self-explanatory. Okay, so I will copy, and the package is TSSOP, and this one this UQFN. Does it mean that 0304 are manufactured only in this strange package? UQFN16. I think I have. No. UQFN12, okay. 12, but there is 16. Both 12 and 16. Okay. Router is 12 and the other ones are 16. And they use 16 because there are some unused pins. 112 to 11. To 11, yeah, that's. I think the 12 package is easier to. Yeah, there are unused ports. Yeah, output enabler is here. In between VCC, here is near the ground, the only reference. I will use the 12 package, 12 port device. 0304. A router, or route, yes. Yeah. And they say 8 kilovolts, and they say 3.6 on both sides, but coming from 0.9. Yes. Yes, 0.6. I will make this string shorter. CCA. CCB, multi-direction, yeah, AD, yes. We have to find verified availability. This is well available. Yeah, maybe I can hit the wall now. No, much better available. Browser. And JL. $1,100 translator voltage. Okay, good. Pin out. Here. 1 is VCC 8, 11 is VCC B, output enable is 12, A1, 210, 3948557, and 6 is the only. Ground. Good. Good. So both voltage translators. This one is not. This is I don't know what's this. Probably a buffer. Some buffer with voltage translation, but I don't know. Translation. Dual supply bus transceiver with configurable voltage level shifting and 3 state outputs. So basically the same as the XB. Probably faster. Yeah, probably faster. They say 380 megabits. The previous one was, yeah, SPI. Yeah, probably. This one was, I don't know, 𝗞𝗶𝗖 50, 100. Yeah, faster. Okay. Yeah, that makes sense. Pickup boy, give me a sec, please. I am back. Everything is fine. Yeah. So as we explained, the second unpopulated or the third unpopulated voltage translator is faster for some control signals, wake in, wake up. I don't know why they need this, is strange to me. But yeah. We'll use the same TXP. I don't know why to complicate the design. Not supported. See the UN board version 3 chapter. Okay. Okay, let's check it. History chapter. UN board revision. Suck it. Okay. So, pin header plus translators. Yeah. And peripherals. Peripherals. Here. Okay, common transistors. No transistors, switches. ESD protection diodes. Here is the dip switch. And I have some dip switches in my on stock. I don't know what. Which ones usually are SDA? Yeah, this is. Yeah. They say 02 H1 SBD, and I have H1 BD. I don't know what's the difference. Yeah, this SMD dip switch, and they say H1 SBD. So let's check the order code. S1 H1 is extended. I don't know what does it mean. SBD is. Oh, I see. I have no SMD. Blank is through hole and S is gullwing. We have gullwing. So it means that my order code is incorrect. No, this is SMD. It's correct. B is gold. S is gullwing. H1 SB. H1 BD. Anyway, I have it. No problem. What else? So two of them. Here are some. Almost transistors. I'm just checking what it is. Just. some multi-purpose small. Yeah, I will use my 7002. This in the SC70, which is, no, this is the FN. I have to correct the description to be visible. Yes. This is a C7, yes. C70, and this is SOT23. Yes, SOT23. Not cheeky. Cheeky, and here. Yes. What else? Nothing. Some details, unimportant details. Okay, this is everything about peripherals. SD card, expansion connector. LPDDR, Ethernet connector. We need this. That's 100 megabit. Yes, 10/100, which can use a standard Mac jack. They use this one, probably some Chinese. Let's check. I have some in my library. Mac jack. Yeah, this one, for instance, this is usually well available. This is expensive, or this one, or this one. Yeah, here is the difference with the position of the lever, or yeah, the metal part of the mechanical part of the connector. So probably this one, and they use this. Oh, I see. Here is extra space. No, it isn't. Oh, this is my history. What's that? What a strange. RMT could be manufacturer. Okay. Don't go on. Cats are going crazy. Yeah. Chinese low cost Mac jack, so I will use. I think I have some on stock. Yeah. Well available or verified. Yeah. Probably this one, or this one is almost the same. I can't remember the Yeah, this is more expensive. I don't know why. 85. Gold. Green yellow LEDs. Green yellow LEDs. I don't know what's the difference. 8-pin 8C. The same. Yeah, I will use it. This, the first one. So let's make a node. Yes. ESD, probably some discrete or a combined solution, but I used the combined ESD protection in the past. This one, ETH, but they stopped manufacturing because it's an Xperia. There is some replacement, but I don't know. They use this one. Very well available. Oh, extremely well available by ST. That makes sense. Yeah. Which is oh, give me the schematic. Which is 4 channel. Yeah, that's practical for it. Ethernet. Yes, no doubt. Yeah, so what's the package? SOT236 over. Okay, I will create this component. I like it because last time I struggled with the ESD protection because I used this 1, 2 of them, and I think, and I was having troubles when sourcing these components. So that's good to see that there are some available USB 0, Ethernet, SIM card. Yeah. Low capacitance, very convenient to solder package. Yeah, that's component I like. So SOT6, 236, or even T as SOT. No, SOT. This is the footprint data sheet. They say it's 4 channel, ultra low capacitance, 4 rail to rail. This is the part number. Let's say Mauser, because we are at Mauser. And GLCPCB says they have it. ESD, okay, and what we need, a symbol. So here, split mode. So IO1 is 1, ground is 2, number 3 is this, number IO3 is number 4, which is let's say input, and one more here, is IO4 here, and there is one more, so the V-bus. Yeah, the V-bus. So the last one will be V-bus. No, the last one. Here. 5, they say. Yes. And it's power in. Well, it's input. Generally, it's input. Nice. No issues. One, 3, 4, and 6, and V-bus is 5. And ground is 2, okay. The package is TSSOP 236. This one. Yes. Okay. So this is Ethernet. Everything is available, just passives, beat. Yeah, nothing special. Everything is in my lab. Library, I want to say. Yeah, here are some. I will have to check the BOM. Do we have BOM? No. Yeah, we do. Here. Probably 0402, C42, C42. C42, 0603, okay, the 10 micros are 03, and 10 nanofarads, 100 nanofarads are C18, 0402, okay. Okay, X7R, okay. X5 are the bigger ones. Yeah, 10 micro in 06 must be X5. That makes sense. Okay. I have everything. Here, these ones will be 0805, I guess, X7, C112. Here. No, even smaller. 0201. Okay. 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 I don't want to place such small components. No. Probably I should. Oh. Oh. Plus, it's not about placing, it's about soldering. Oh. Can we go with 08, 04, 02? That's inconvenient. Manufacturing. Assembly. These caps are around PMIC. The PMIC is U7. U7 here. No, that's not PMIC, it's the PM MPU. Okay, now I can see. That's the bottom layer. Here. Here. Probably all these. C112. Yes, here. Not good. This will be easy to PCB layout, easy to connect, but difficult to solder. Oh. And it will be, okay, never mind. So here is basically everything. The passives will be easy to create. Yeah, here C15 will be 0805 probably. C15 here, no, 0603, that's fine. No. Here, and I'm interested in the inductors L2. 𝗲806 Murata. Quite well available. It seems to be a normal component. Yeah. Usually these chip inductors are not so good because the the DC resistance is high and is high and the saturation current is rather small. Yeah, DC 43, which is not so bad, and rated current is 4.3. The saturation current is not stated here, but based on the temperature rise 3.1. So yeah. Okay, that's good. Okay, a button. That's, yeah, some headers, crystals. Yeah, just for my, what's the crystal X2? Last week I dealt with an issue with the boot loading for the STM32MP215F, and we found that the 40 megahertz crystals, as we used, I think we used, are not recommended, or no, yeah, they are recommended, but the 8 megahertz ones are more stable for the boot up. So X2, I'm just interested what's the ppm value of these. 20 ppm, so nothing special. Yeah, I already understand. This is some low-cost Chinese. Yeah. Yeah. I will use the better ones. 15 or 10 ppm if possible. Yeah. Okay, nothing here, and here is the first. So quick check USB, LCD. We said that we won't use LCD. SD card, yeah, ESD protection. We can use the previously created one, so they could as well, but they didn't. Camera interface, no. Expansion, no. M2 connectors, yes, and passives only. Peripherals are easy. Okay. So let's conclude this session. Basically all our symbols are ready, and we are in front of the shorter vacation because the Easter holiday is starting tomorrow. I will do my best to work for at least a few hours on this design. I will try to start with the schematic of the MPU, because yeah, as you can see, there is nothing special, just at least here just labels, just wires with labels. So what we need to be is to be extremely careful about the placement. Other option, or an option, is but I don't want to do it, is to create the same symbols and then to import the schematic. But I don't know if we have the design files. I think I downloaded only PDFs. Mechanical ODB. Oh, we have ODB, but it's not what I am talking about. Manufacturing. Maybe there are some design files, but yeah. Okay. Last but not least, if you want to support me, frankly, today I haven't done much, but still, if you like what I do, and if you want to start with KiCad, I recorded and created about 3.5 hour long basic/essentials for KiCad. It's available at 𝗞𝗶𝗀.com. It's called KiCad for Beginners. And the let me here is the link, and you will learn essentials for this power supply. So symbol creation, footprint creation, 3D models, schematic capture, PCB layout, manufacturing data export, importing graphics, routing, everything. There is a special yeah, I don't know how to say. If you enroll the course, you will receive within 30 days a coupon for next PCB, and then you can redeem this coupon at nextpcb.com, and you will receive the fully assembled PCB. So if you when you finish the PCB, then you will receive the entire assembly. And see, if you enroll for 49 euros, you will easily receive the same value, maybe more, in the assembly. So, and you will have something on hand. That's always good, I think. And if you are more than beginner, I created this, and here is the link, KiCad for Makers, which is something that you can continue after finishing the PCB for beginners, or if you are already an advanced user, you can design with me this 2 power supplies, M2 connector, dual core RP2350 MCU, 2 USBs, 4 analog inputs, 4 analog outputs. Yeah, everything is there. So in this, you will repeat everything you already know, and you will build on your skills and knowledge. And the same thing with the next PCB here. If you enroll after 30 days or within 30 days, you will receive the coupon for next PCB, and you will receive this assembly with all components. And again, if you enroll for 69 euros, you will receive about $100 assembly. So I think for some of you, that can be a no-brainer. I'm here. Yeah, a no-brainer. So yeah, yeah, that's something from me. See you next week. Bye-bye.